Okay, Assalamualaikum and selamat sejahtera. Okay, so hari ni kita continue with new subtopics under structures. So, which is, okay, under structures. So, the subtopic is method of sections. Okay, before ni kita dah belajar about method of joins. Okay, so sekarang now we look at method of sections. Okay, so here, yes, okay, first thing first is, okay, the external reactions are first computed. Okay, first we have to compute the external reactions. Okay, with the method of joins. Okay, by considering the truss as a whole. Okay, so we have to compute first. Okay, let's say we have to know the external reaction. In this case, we have to know R1, L, and R2. Okay. Okay, and then let's say we have to determine the force in the member BE. Okay, so next is BE. Okay, we want to know the force. Okay, so what we have to do is, okay, we just draw an imaginary section. Okay, okay, indicated by the dash line. Okay, so kita akan draw satu imaginary line. Okay, kat sini. Which means kita cut into two sections. Okay, so we cut into two parts. Okay, and then okay, so what we have to do is next kita kena determine dia punya, what is it, dia punya force. Okay, either it is tension or compression. Okay, and as well for the line, line sini. So mana kita kena make sure we have to assume lah. If we don't know, we just assume. Okay, what is the force here? Okay, type of forces here and here. Okay, okay, so in this case, okay, this one is under, okay, kita tengok juga based on external force ni. Okay, let's say, okay, based on this external force, okay, external force, okay, kita assume this one to be under tension. Okay, and then this one under compression. Okay, and then this one, okay, dia macam ni, so it is under tension. Okay, okay, so senang je, we assume first, kalau let's say dapat, let's say macam ni kan, let's say BE tu we get negative. Okay, which mean dia bukanlah tension, it will be opposite. It means under compression. Okay, okay, so next, kejap apa dia. Okay, so next is, okay, so there is extra part here. Okay, cutting section mana? Cutting section, okay. Cutting section is preferably passed through the members, okay, and not the joint. Okay, maksudnya tengah-tengah members tu, tengah-tengah, what we call it, besi tu. Okay, and then, okay, so simple je. Okay, so we just go straight to the example. Okay, so now we have, okay, this is the example. Okay, so the question is, okay, calculate the forces induced in members KL, CL, and CB. Okay, by 20 ton load on the cantilever truss. Okay, so keyword here is we have to determine forces for member KL, CL and CB. Okay, mana tu? This is the KL, CL and CB. Okay, so meanings that kita kena cut section where? We have to cut section through the members. Okay, that is the first thing we have to cut. Where's the part that we have to cut? Okay, and then okay, so here I just highlight the same point that I mentioned. Okay, we may pass a section directly through members KL, CL and CB. Okay, and then we analyze the portion of the truss to the left. Okay, which means kita akan analyze dia to the left. Okay, so color. So maksudnya meaning, okay, we are going to analyze this part, okay, to the left. Okay, that's it. Okay, so this is I just copy the figure, okay, make it larger. Okay, so this is the body. Okay, so this is the body. I'm going to analyze this part, okay. So first we assume that, okay, so okay, macam mana nak tengok to determine the force type for KL, this one, KL, CL and CB ni kan. Okay, so what we have to do is we look at the external force. Okay, external force ni is going downward kan. Okay, so which means here maksudnya, okay, this is the support kan, this is the support, this is the support. Okay, so which means bila benda ni tarik ke bawah, this one will be going under tension. Okay, tension. And this one also going under, it will be this one. Bila dia tarik, okay, this one will be compressed. Okay, so which means, so this one we will look at this one only. Okay, so this one, yeah. Okay, so this one will be like this. Okay, dia punya ni, this is the force. Nampak apa? Tak with different colour. This one. Okay, so it will be in this way and in this way. Okay. Okay. Yang this one, yang CL ni, we just get IV first. Okay, later we deal with CL. Okay. Okay, then P. Yes. Okay, next. Okay, so sekarang, okay, based on the textbook, okay, we have to determine the summation at L. Okay, summation of moment at L. Okay, summation of moment at ML. Okay. So this one, kalau method of section ni dia banyak deal with with moment. Okay, summation of moment equal to 0. Okay. So here, okay, so we take at joint L. Okay, joint L first. Okay, so okay, this is L. Okay, yeah, L here. Okay, so summation of ML should be equal to 0. This one is under equilibrium condition. Okay. First, identify. Force apa yang kita nak calculate for moment at L ni? Apa force yang ada? Okay. First, of course, this one. Okay. And then, we have this one. Si apa ni? We have this one kan? Apa ni? Under compression kan? Okay. And then, so what we have to do is, okay. So moment, remember, moment is F multiply with distance kan? Okay, this one 90 degree lah with 90 degree punya sudut. Okay, so first we take this one. Okay, we have 20. Okay, 20 times. Okay, in this direction. Okay, and then going to the L, right? Okay, so L, the distance is okay until here. Okay, so which means 1 2 3 1 2 3 4 5. Okay, dia punya distance is 5 multiply with 12. Okay, so each panel ni dia punya distance is 12. 12. Okay, so we multiply with 5 12. Okay, so in this direction. Okay, so this one is using right hand, right? Okay, so it will be positive. Okay, positive. Okay, and then next is we have this one. Maybe I should color with different. Okay, this one. Okay, so and then okay for this one, we have BC, right? CB or BC is up to you. Okay, we have, let's say, BC lah. Okay, BC. And then BC is in this direction. Okay. And then distance to L is, okay, this one is, okay, so we have, okay, this one is 16, right? Okay, 16. Okay, this one same distance. Okay, this one is, the difference is 10. Okay, 26 minus 16, we get 10 here. Okay, so since the distance is same, the horizontal distance is same, so this one, we just divide 2. So 10 divided by 2 will be 5. Okay, so which means the distance is 16 plus 5. Okay, upward. Okay, so so this one is using left hand. Okay, so left hand is negative. So negative. So it will be negative here, and then equal to 0. Okay, why we don't calculate for CL and let's say this way, and KL, because it is in what we call it, same direction with the CL, with the moment of L. Okay, so no need, so we just focus on this one. Okay, so now we can calculate CB. Okay, so we will get, this one is 1200 minus 21 CB equal to 0. So CB or BC is equal to 57.14. Okay, now we settle for BC. Now we have to calculate KL and CL. Okay, so next we are going to copy this figure. Okay, copy. Okay, and this one. paste. Okay, so next we are going to calculate moment at C. Okay, so moment at C. Next is moment at C. Okay, summation of moment at C equal to 0. Okay, so we have to determine what force we have to calculate. Okay, FD for moment. Okay, so this one we have to calculate, and then okay, we have to calculate. Okay, this one no need because same direction with moment of C. Okay, same direction, and then we have to calculate the KL. Okay, KL here. Okay, so in this case we have to determine the okay, so this one. Okay, in this case we have okay to determine the angle here. Okay, let's say we give it theta. Okay, so how we want to determine theta? So just use tangent. Okay, tangent theta. Okay, so it is what is it? Sebelah over tentang. Okay, so sebelah is here. So this one we know it is 5. Okay, sebelah tentang over sebelah. Okay, and then sebelah here is the distance is 12. Okay, so 5 over 12. Okay, and then theta we will get 22.6. One or 6 also can. Okay, 6 degree. Okay, so that's it. So we have two force here, which is this one and this one. Okay, so now it's time to calculate. Okay, so we take the external force first, which is 20. Okay, 20 times downward. Okay, and then going to C, which is 1, 2, 3, 4. Okay, 4 multiply with 12 in this direction. So it is using right hand, right? The direction, so it's positive. Okay, and then next is the KL. Okay, KL cos KL cos 22.61 degree. Okay, so it is in this way, right? Okay, the force. Okay, and then the distance is going to the C, which is 16. Okay, so multiply with 16. Okay, so it is downward, right? Okay, so downward. So we have to go like this. So it is using the left hand. Okay, so it is negative. So this is negative equal to 0. Okay. Okay. We don't calculate this one. Why? Because it is in same direction with C. Okay. So there's no need. So no need. Okay. So that's it. So calculate. 960 minus 14.77 KL equal to 0. So KL we get equal to 64.99 or 65. Okay, so settle for KL. So next is we don't know. The only one we don't know is CL. Okay. So for CL we have to use another point for momentum. Okay, so we have to determine using P. Okay, so where is this P? Okay, so we just drag. Okay, maybe this one. Okay, so we just drag. This one. Okay. Okay, this one is actually a line that is not straight, right? Okay. Okay, so we just drag this one. Okay, extend the line. Okay. Like this. One, two, three, four. 1, 2, 8, 58. Okay. Okay, let's see. Okay, it's like this, okay? So this is point P, let's say, okay? This is point P, okay. So this is the triangle that we want, okay? Okay, so like this, okay? Okay, finally. Okay, then, okay, how to determine the distance? Okay, so this time we have to use comparison concept, okay? So notice that, okay, we can compare with this triangle, okay? Okay, so because we know the distance, this one, the distance is 10, okay? Which is 26 minus 16, okay? And then this one is 12 multiplied by 2, we know it is 24, okay? So, okay, so for this one, we know the distance is 16. So what we don't know is this distance, okay? We name it as PC, okay? So, here we have PC, okay, we don't know. It is equivalent to 24, okay? And then the vertical distance is 16, okay, is equivalent to 10. Okay, so now we calculate, we get PC equal to 38.4, okay? Then next, okay. Okay, so let's see. Okay, and then we have to determine what is the force that we have to calculate for summation at P, moment at P, okay? So we have, okay, let's see here, summation moment at P, P equal to 0, okay? Remember the formula F multiplied with T. Okay, so this is external force, and then, okay, we have to calculate the CL, okay? The CL, okay, CL is, okay, so here we assume, okay, we assume CL is under compression, okay? So we just put it like this, okay? So this is the CL, okay? Okay, so now we have to determine the angle, okay? So the angle is in this way, okay? In this way and in this way. Okay. So which means we have to determine the angle here. Okay. So it's time we name it as let's say beta. Okay, so how we want to determine the beta? Okay. Okay, so again we have to know. Okay, let's say we just use the concept of tangent. Okay, so we know this one, which is 12. Okay, and then we know this one, which is the distance. Okay, which is 16 plus 5, which is 21. Okay, so tangent beta is 12 over 21. Okay, so beta we will get how much? 29.7 degree. Okay. So and then okay, so now we calculate the what we call it. Okay, so here, so this is the point. Okay, so which is basically the one that we want to calculate is like this. Okay, so this one we don't have to calculate, only this one. Okay, which is which means this one. Okay, so okay, so now we can calculate the summation of moment at P. Okay. So we calculate the, let's say the external first. Okay. Okay. So 20 ton, okay, downward, the force direction, and then going for P, okay, for P, which is this one. Okay, so we don't know the distance. Okay, so what we know is, okay, this one, so PC we know. Okay, PC is how much? 38.4, right? Okay, so 38.4. Okay, the whole distance is, okay, the whole distance is, okay, okay, let's say this one is 1, 2, 3, 4. 4 multiplied with 12, which is 48. Okay, and then we know PC. Okay, PC is 38.4. So this one we just 48 minus 38.4. Okay, so the direction is this one. Okay, so this one. Okay, so we have positive. Okay, and then for the CL, okay, CL we have, okay, CL cos, what is it again? 29.7 degree downward. Okay, and then we just multiply with the distance of PC, which is 38.4. Okay, so this way. So this one is left hand side, so it is negative. Okay, then we just equal to 0. Okay, so we calculate, we get 192 minus 33.35 CL equal to 0. So CL is CL equal to 5.75 times. Okay, so everything is in ton unit. Okay, so that's it, how to calculate the members. Okay, that's it for to this topic. Okay, thank you for your time.